Inscribed angles aren't the only angles that are half as important as central angles. What happens when a tangent intersects a chord at an endpoint? We get the tangent-chord angle theorem. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Wow, imagine that. So here is chord JP and tangent ray PN, and they intercept arc PJ. That means that the measure of angle JPN is equal to half the measure of arc PJ. There are three cases of this situation. Case 1 is if the chord is a diameter. This is really easy to prove, because if the chord is the diameter, half the chord, segment CP, is a radius, and we have the radius tangent theorem, which says that a tangent is perpendicular to a radius at the point of tangency, and since the arc associated with the diameter is a semicircle, let's see, perpendicular, 90-degree angle, semicircle, 180 degrees, half. We're done. Case 2 is that the chord and the angle intercept a minor arc, and case 3, the chord and the tangent intercept a major arc. So these are the three cases. I'm going to take some time to prove case 3 right now. Case 2 is very similar to it. So here's case 3. Notice that I've added in segment XP, a diameter, as an auxiliary line. That's going to be helpful because now we can say from case 1 that the measure of angle XPR is half the measure of arc XAP. Notice that angle JPX is an inscribed angle, so the inscribed angles theorem tells us that the measure of angle JPX is equal to half the measure of arc JX. So let's just do the addition property of equality. Since the measure of angle XPR is half the measure of arc XAP, we can add that to both sides of this other equation. So we get the measure of angle JPX plus the measure of angle XPR is equal to half the measure of arc JX plus half the measure of arc XAP. Again, that's the addition property of equality. So let's do some simplifying here. Notice that the measure of these two angles happens to be the measure of the big angle. So the measure of angle JPR is half the measure of both of those arcs. That is the angle addition postulate. Now, I'm going to use the distributive property of multiplication over addition in reverse here and pull this 1/2 outside the parentheses. So now we have the measure of angle JPR is equal to half of the two arc measures added together. But wait a minute. The two arc measures added together are the measure of the entire arc. So the measure of angle JPR is half the measure of arc JXP. And that's the arc addition postulate. Boom, we're done. Not really difficult, but kind of tricky. The case 2 is exactly the same, except that you'll be subtracting the angle and arc measures instead of adding them. So now let's give it a try. In the diagram, line LN is tangent to circle P at G. Deduce the measure of angle AGL. That would be the acute angle on the right side. I think that the best way to start is to take a look at the arcs. You will notice that the major arc is 222 degrees, so we can find the measure of the minor arc by subtracting 220 degrees from 360 degrees. So the measure of arc AG is 138 degrees. And now that we know the measure of the arc, we can use the tangent-chord angle theorem to find the measure of angle AGL because it's going to be half of the intercepted arc, which is arc AG, and so that means it's half of 138 degrees. And of course, half of 138 degrees is 69 degrees. So the tangent-chord angle theorem, very easy to apply. All that we will be doing is either multiplying or dividing by 2 in order to use it.